Welcome to this training video about the MEDINA component Codyze. This presentation is divided into 4 parts. First, it gives an overview over the purpose of the component and its role in the MEDINA framework. Second, it shows how to use it, including a short demonstration, and how to install it. Finally, further information is given to follow up on MEDINA resources. The MEDINA framework aims at supporting continuous security certification of cloud services. It focuses on the European Cybersecurity Certification Scheme for cloud services and the requirements it defines. Typically, such certifications are conducted infrequently, for instance once a year, as they involve considerable manual work. The components that have been developed in the MEDINA project support the automated and continuous checking of the respective certification criteria. Codyze supports this framework by providing assessment results for cloud services. Let's start with an overview of what their purpose is. Codyze is a compliance assessment tool that is used during software development. It identifies non-compliant features in source code and source code repositories. It enforces proper uses of TLS and data encryption in source code. Moreover, it enforces provenance on submissions to a source code repository. Through these features, Codyze contributes to more secure development processes. It highlights insecure implementations early during development when they are easier and cheaper to fix. It provides mitigations to developers to enable them to implement proper fixes. Finally, Codyze prevents the deployment of non-compliant software products. The strength of Codyze is best used when it is integrated into a CI/CD pipeline. As part of a pipeline, it acts as a compliance assurance gate. When developers push new code to a source code repository, a new run of the CI/CD pipeline is triggered. With the integration of Codyze, the source code is automatically checked for compliant implementations and provenance. If the software meets all compliance requirements, it is deployed. Otherwise, Codyze prevents the deployment. In addition, Codyze reports the results of the compliance checks as assessment results to the orchestrator within the MEDINA framework for further processing. Thus, stakeholders can review the results. Here, you can see the complete MEDINA framework, including Codyze. We can see Codyze interactions with cloud services and the orchestrator. Here's a complete list of the interactions of Codyze with other MEDINA components. To the orchestrator, Codyze sends assessment results regarding the analyzed software. Moreover, Codyze is part of the CI/CD pipelines for cloud services to scan new code submissions and assess compliance automatically. For more details on the orchestrator, refer to its training material. Let's now look into more technical functionalities and a demo. With respect to the source code, Codyze performs static code analysis for C, C++, and Java projects. It analyzes the proper usage of APIs. The underlying premise is that the behavior of APIs is bound to function calls and arguments. Secure and correct usages of APIs rely on the use of good arguments and the proper order of function calls. Thus, Codyze verifies arguments and function call orders. It uses a DSL called mark to specify how APIs should be used correctly and securely. The DSL defines entities that model API functions and their parameters. Based on entity specifications, rules enforce restrictions on function arguments and function call orders. Here we show 2 examples in the DSL. On the left side is the definition of an entity for Java's JSSE. It defines an SSL server socket that maps to the respective Java class. Moreover, the entity tracks a function that configures the enabled SSL TLS protocol versions. The interesting parameter is called protocols. With this entity definition, a rule is specified as shown on the right side. This rule restricts the allow protocol versions to TLS version 1.2 and TLS version 1.3. These 2 versions are currently the officially recommended TLS protocol versions, enforcing compliant transport encryption. Codyze also supports human-readable messages for its rules in its DSL. These assist developers in understanding the issue with non-compliant implementations and offers mitigation help. The example shows messages with respect to TLS protocol versions. The results from the source code analysis must be mapped to MEDINA metrics for further processing within the MEDINA framework. The example shows a mapping of MEDINA's TLS version metric onto the Codyze rule TLS version. Codyze supports the definition of rule sets. These are directory-based. A rule set consists of the definitions of entities and rules in its DSL as MARC files, human-readable messages through the finding description, JSON file, and the mapping to MEDINA metrics through mapping YAML. With Codyze, two rule sets are pre-defined and distributed. One rule set checks TLS usage through Java's JSSE API. The second rule set verifies Java's JCA/JCE API usage for data encryption. Beyond these two predefined rule sets, it's possible to create new ones. Aside from Codyze's source code analysis, it also looks at the provenance of code submissions. It ensures that submissions come from authorized developers. To this end, Codyze checks Git commit messages and checks sign-offs and commit signatures. The respective configuration of authorized code authors and their credentials is shown. Codyze generates reports from its analysis. The report from the source code analysis is in the SARIF format. SARIF is a standardized interchange format to describe results from static code analysis. Codyze also integrates the provenance results in the same SARIF report. This SARIF report can be integrated into the development platforms to highlight violations to developers or automatically open issues in an issue tracker. Moreover, the results from Codyze are also submitted to the orchestrator as assessment results for further processing and tracking of compliance. In this demo, we are going to analyze a demo cloud service. This service implements a TLS endpoint using Java JSSE. This API allows the configuration of a TLS socket. Among the possible configuration options are the offered TLS version and TLS cipher suites. As part of the demo, this implementation has been configured to use deprecated TLS cipher suites, resulting in compliance violations. The actual details are not relevant for this demo. Let's look at the project's content. The project contains configuration files for Codyze. These files are Codyze MEDINA YAML and Codyze MEDINA metrics YAML. Within Codyze MEDINA YAML, we define the connection to the orchestrator. This connection requires authentication. The authentication credentials are included in the configuration file for simplicity. In production scenarios, one would inject these credentials securely through the CI/CD pipeline. Afterwards, we configure the ID for the cloud service that we're analyzing. The ID is required to map the results from Codyze to the respective cloud service within the orchestrator. We reference the provenance metrics stored in Codyze MEDINA metrics YAML. We also select the rule set that Codyze evaluates. In our case, it's the rule set for Java's JSSE. As project structures can vary, Codyze needs to know where the sources are that need to be analyzed. The path is configured as shown. Finally, the SARIF report from Codyze is stored in the specified file. This report could be used to reflect compliance violations back to developers using development platforms and issue tracker. Let's now look at Codyze MEDINA metrics YAML. It identifies authorized code authors and tracks code provenance. Using the default Codyze configuration file names, running Codyze is as simple as calling it. If no arguments are provided, Codyze uses sensible defaults. After the analysis finishes, we see that Codyze has identified violations. This is expected with this demo project. If we were in a CI/CD pipeline, these violations would abort the pipeline execution and prevent the deployment of a non-compliant cloud service. We can take a look at the SARIF report. As mentioned previously, this report could be integrated to provide feedback concerning the violations to developers. The details are not relevant for this demonstration. In addition to the SARIF report, Codyze submits its results as assessment results to the MEDINA orchestrator. Let's take a look how the results are integrated. On the MEDINA UI, we identified the cloud service for which we just submitted assessment results. This is the Codyze demo service. The ID matches the one we configured in Codyze MEDINA YAML. We can select this cloud service to browse the available assessment results. The UI shows compliant and non-compliant metrics for our demo cloud service. The results are as expected for this demo. With this, we conclude our demonstration of Codyze. Thank you for your attention. Let's now review some installation details. Codyze is distributed as archive, container image, and source code. The archive contains pre-built binaries of Codyze for the Java VM. The container image bundles Codyze with a Java environment. From source code, an archive or a container image can be built. For the integration into a CI/CD pipeline, the most suitable distribution can be used. The details of the integration depend on the platform. Due to the many choices, details cannot be provided here. With the integration of Codyze, projects can be analyzed automatically during pipeline runs. Codyze offers templates to ease the configuration of projects. Project-specific configuration files should be included in the project's source code repository. This way, Codyze uses them during pipeline execution. Moreover, Codyze's configuration is managed consistently within a project. Finally, it's possible to integrate Codyze's SARIF report into a development platform to create issues for developers and highlight violations in source code. Codyze for MEDINA is written in Kotlin. It uses the Gradle build system through the Gradle wrapper. The DSL is developed using Eclipse Xtext. Finally, Codyze is bundled with the predefined rule set specified in the DSL. There is lots of further information about the MEDINA project. The MEDINA website contains the public deliverables, scientific publications, as well as many other useful information. Our YouTube channel comprises more videos, especially for training. The MEDINA Zenodo community and the source code repositories also hold documents and source code for further reading and development. Thank you for watching this training video. Goodbye.